So to solve a rational equation, we're really going to, it's not too different. It's very similar to how you've solved equations with fractions in the past. So basically, we're going to multiply by common denominators to clear out the fraction. When you were in grade 11 and previously in this course, when you were simplifying rational expressions, you don't have a right side of an equation to deal with. It was not an equation. You can't do something to both sides and keep it balanced, right? That's something to think about. People take that for granted, but when you have an equation, we can do that. Prior to, it wasn't an equation, we couldn't do that. So we were just simplifying. Now that it's an equation, in other words, I can do this. Multiply both sides by x plus 3 and x plus 3. And so I get x plus 2 over x plus 3 equals 2 times x plus 3. Multiply both sides by x plus 3. On the left side, they divide to 1. But remember, we have to keep in mind restriction. So at any point in the process, you can't divide by 0. So we have this restriction, x not equal to negative 3. But the restrictions in this are a little bit different. So we're going to write it down to keep track of it, finish solving this, and then come back and talk about how this restriction is different from previous restrictions. So x plus 2 equals 2 times x plus 3 is 2x plus 6. I end up with negative x equals 4x equals negative 4. And if I do a quick check in the original equation, it looks good to me. Negative 4 plus 2 over negative 4 plus 3 gives you positive 2, so I think we're good. So somebody tell me something about my restriction. Alex. Something else? Uh-huh. So what do you mean by that? What does Alex mean by that? If that were a function, yeah, if it were equal to y, but it's equal to 2, it's not even equal to 0 or anything like that, so it's a little bit different. Like, this is the thing, when you have to understand, think about what it is we just did. What does it mean to solve an equation?
Find the x value, and you're saying that x cannot equal negative 3. Well, it can't because it's
Right. X cannot equal negative 3, but it doesn't. So it's not really a restriction. Like x can't equal negative 3, and it doesn't equal negative 3. X isn't negative 3. So like restrictions when you're solving an equation only really come up once in a while. I think this is important to think about, and it's, to me, like every course when you are graphing and solving equations, it's important, even though it's a simple concept, sometimes simple concepts have a lot more depth to them. And when you think about what it is we're doing here compared to what we're doing when we're graphing or thinking about functions, it's very different. We're solving to find the x that balances it. Up here we said it can't be negative 3. Well, it's not. So what kind of weird restriction is that, right? It's just kind of weird. So the lesson here does say don't forget to state any restrictions, but I would say technically you wouldn't, if you're solving an equation, you wouldn't have to state a restriction. That's not really a thing. Now, once in a while, it's going to come into play, and in that case, you have to account for it. We're going to see that in the next example, I think. Okay, but but it's different. Okay, let's move on to the next one. I think there's a typo here. It's supposed to be 21. There's a different order that you might do these questions in. And so whatever order you do it, like the specifics might look a little bit different, but I'm going to do it one way. And if you end up doing it a different way, it's not a big deal. But so I'm not saying this is how you have to do it. First things I want to think about is I'm going to just think about my restrictions. So what can X, what won't work as a value for X? So I'm going to do this off to the side. Like you could factor in the question, that would be fine, but I'm going to do it off to the side. So X squared minus 4X minus 21 is X minus 7, X plus 3. So X cannot equal 7 or negative 3. Is that correct? Are we all good with that? So those are, me just kind of thinking about what X can't be. Now I'm going to multiply both sides by the denominator. So I get X plus 3 over X squared minus 4X minus 21 equals 1. Multiply by X squared minus, you don't have to show this step either this way, but we're going to do a couple of examples that are a bit trickier, and it's nice to, again, have a system that we can fall back on when things get a little bit more complicated. So multiply both sides. These divide to 1, and I get X plus 3 equals X squared minus 4X minus 21. How do I solve an equation like this? It's very different from the last one.
Move X plus 3 to the other side.
Okay, great. So 0 equals X squared minus 5X minus 24. Does that look right to you? Okay, nice, right? So it's a quadratic equation now that we're just solving. And how do I solve this? It looks like it's factorable. Minus 8X plus 3. Therefore, X equals 8 and X equals negative 3. Aha! Inadmissible. Because of restriction. Does that make sense? See what I mean? Yep.
Well, if you were to factor the quadratic in the first place, you just end up with X equal to 8 because you'd be canceling out the X plus 3.
Yeah, that's right. So depending on how you do it, it might work out this way or things may work out a different way. Nevertheless, it's something you want to think about.
So is it still right to do it like just factoring this one?
Yeah, doing it that way would be fine. Any other questions? Okay, let's try a couple others. Just different kinds of questions. So, what I would do is I would make a note to myself, X can't equal 0. And then when I finish, go back and check those restrictions. You're not going to have very many of them. You might have one like this or two or something like that, but it's probably a good idea. Otherwise, you just might forget about it in the end. So how am I going to solve this one? I'm going to multiply by a common denominator to clear out all the fractions. And I'm going to do it, so a common denominator would, like you could multiply denominators together, right? So 3x would be, but here's a nice way to do it. Just multiply by each of those things individually. It's kind of long, but honestly, in some cases, if you're panicking on a test or if all of a sudden you have a really long question and you're losing track of terms or something, then this can be a nice way to do it. Right? So in this case, those divide, those divide, those divide. And I end up with 3 times 1, which is 3, plus x squared, plus 15. No, sorry, equals 15. And you ever get a question like this, you would absolutely reduce it. Leave it as exact though. Does it seem easy?
Did you have to write out restrictions for a question like that?
Well, no, like I made myself a note, x doesn't equal 0, but then it doesn't. So we're fine. Like if you didn't write x can't equal 0, you'd still get full marks. If for a question like this, at the end you didn't say x equals -3 is inadmissible as a solution, then you would lose marks because it can't be, right? And like not necessarily every question things will factor out on their own. Restrictions is something you have to take into consideration as you're doing it. But often the restrictions end up being irrelevant anyway. Does that make sense? Okay. We're gonna do one more. Any other questions? So this is the same idea with C, but instead of just multiplying by x and by 3, we're multiplying binomials. What can I multiply through on both sides that will clear all of the denominators, right? That's what we're figuring out. So I'm going to multiply just the one time by each of the denominators. So x plus 2, x plus 3 times 2 over x plus 2 plus x plus 2, x plus 3 times 1 over x plus 3 equals x plus 2, x plus 3, 1 over x plus 2. Okay, I'm going to let you try to go ahead and simplify that. I got -5 over 2. And I didn't write down restrictions, so then you want to go back and make sure that that's not for some reason restricted. That'd be a little bit weird if there was one answer and it was in the restrictions, but it's not impossible. The first question, x can equal -2 or -3, and it doesn't, so we're good, right? So perfectly fine. Any questions? Okay, remember, tomorrow we're doing solving inequalities, and it is quite different. Different in like you know how when we solved linear inequalities in the previous unit, it was kind of the same, but then polynomial inequalities was different, right? We had to use that number line stuff. Similar idea where the way that we solve it, the way we go about solving is very different in rational functions from how we solve these equations. So keep in mind that, yeah, maybe this seems a little bit easy, but this is something you want to be really good at, you want to be able to do quickly, and you want to be good enough that you don't get it muddled up with the other kinds of techniques. Okay, so for the rest of the period, what we're going to do, here's the homework if you want to write it down. Five to 10 are not meant to be like challenge questions. They're in a bracket because you only do ACE for those. So 1 to 4, 5 to 10 ACE, and then 15, 16 would be challenge questions. So here's what you can do. You finish your learning goal. And here is a next week. I think we're going to do it next week, like maybe Tuesday. We're going to do an activity where we're going to do some modeling with rational functions. So here's your first chance to try. Now this is difficult. It's meant to be difficult. You can work in partners. So you could take like 5 or 10 minutes right now. Yeah, we got lots of time to see if you can come up with an equation that would solve this problem. It's like going to be new thinking. It's going to be modeling in a way you probably haven't really done yet. So we're going to try it, see how far you can get. And then next week we're going to do more and like more complicated ones. But if you can even kind of start thinking about this now, it'll help a lot for next week when we revisit it. Okay? And I will take this up, but I'm going to leave this now. So you can finish your learning goal as well as work on this and as well as the homework.